Morning, everyone. Welcome to day 4 of Math 133. Today, we're going to cover the Chapter 3, Project 1. Um, if we have some extra time, we'll probably go over the 2.3 Google Sheet project. We didn't get to do last time we met. We did the Chapter 2 review worksheet Google project, but the 2.3 notes Google Sheet project is very similar. Okay. But today, Chapter 3, Project 1 is all about mean, median, and mode with StatCrunch. Okay. If you click on it in Canvas, so let's click on Chapter 3, Project 1 in Canvas. It says click on this link to get to the Google document, which is where we're going to fill in all of our answers. Most of our projects are going to be in the Google documents. Most of our worksheets are going to be in the course pack. Okay. So here it is. This is what we're going to be working on today, and I will drop this in the chat just so you don't have to go search for it. So this is where we're going to be filling in our answers, but we can't fill it in here. We are going to need to make a copy, right? So we're going to click on File, Make a Copy. Okay. And I'm going to call this is Spring 2026, and there we go. Okay. You don't have to change the name. If you want to just leave it as is, that's okay. Uh, and I'm going to save it in my drive, right? Make a copy. All right, there we go. Um, all right, so now I can start filling things in, right? Okay. So mean median mode with StatCrunch, we're going to find a publicly available data set on StatCrunch that's interesting to you. Just like we did for the Chapter 2 project. And you can actually use the same data set. Well, okay, let's check because it says your data set needs to have at least one quantitative variable. So last time when we did the Chapter 2 project, it had to have two qualitative variables and one quantitative variable. In this case, I just need one quantitative variable, but it's got to have a lot of numbers, a lot of variability, and a lot of repetition. Okay. Okay, so let's go to StatCrunch and let's take a look. So type in statcrunch.com. Don't close the Google Sheet because that's where we're going to be entering our answers, right? So open a new window, type in statcrunch.com. In the upper right, where it says sign in or register, you're going to click on that. Okay, and then fill in your fill in your Pearson information. Okay. Make sure that you've got this username and password somewhere. Don't just rely on your computer having it saved in its memory. I would actually write this one down. Okay. Um, uh, on test day, you're allowed to use StatCrunch, statcrunch.com. And what I would hate is for your cache to get cleared, and now your username and passwords are not memorized anymore, and you don't have a way to get in. Uh, that's going to be a problem. So on test day, you're allowed to have an 8.5 by 11 piece of paper, front and back, and you can write your username and password for Pearson on that. Okay. Um, okay. So once you've done that, this orange button should light up. Don't click on the orange button though. We want to click over here on the left on data sets. Okay. So once you're logged in, we'll click on data sets. James, you said that it's not letting you make a copy, so do file, make a copy, and then make sure you change the folder because this folder right here, the Math 133 projects for fall through summer 2026, this folder is not someplace that you can save. So you'll want to click on that and change the folder. I saved today in my drive, but you can make your own folder. So like if you have a location that you can save it. Uh, so I've been putting some of mine in like this Math 133 Spring 2026 folder that I created. But you can just click on all locations and click my drive. Okay. All right. Okay, so we need to make sure that uh we need to make sure that we have a data set that has a column that's quantitative. And almost all of these are going to have a quantitative column, actually. It needs to be big enough. So, um, like I said before, I probably wouldn't use this professor salaries one. It's a little too small. It's only 7,000 kilobytes. But the rest of these should all be fine. Um, so I'm gonna look for baseball. And I'm gonna do this one. So this one has 335,000 kilobytes. So this one's plenty big enough. Um, but since I'm doing this one, it means you're not going to be able to use this one. But you can use one of the other ones here. There's a couple other baseball ones here. So if you're interested in baseball. So I'm going to be using every 2013 Major League Baseball home run. Okay. Um, all right. So Uh, let's go back over to our project. So question one is what data set did you choose? What you'll do is you're going to grab the URL in the address, okay? Right click on that, hit Control C, okay? Or copy it, and then you're going to come over here and you hit Control V or right click and paste, okay? There we go. So that when I'm grading it, I'll be able to go and look at what data set you picked. Okay. All right. Question two, why is this data set of interest to you? So you can't just pick a random data set. You have to pick one that you actually care about, one that you're interested in. So I picked this one because I did a summer research uh, internship on the aerodynamics of baseball. So, which is actually true. I once did a summer internship at the University of Illinois in Champaign-Urbana. Uh, I worked with a physics professor there, and we studied the physics of baseball. So the question we were trying to answer is, um, if you hit a baseball, which goes farther, a fastball or a curveball? So if a pitcher throws a fastball at you and the fastball is moving faster, so when you hit it off the bat, it's going to leave the bat faster. Is that one going to travel farther, or is a curveball going to travel farther? So a curveball is going to be moving slower, but it's going to be spinning much faster. And when you hit it, it's going to leave the bat with backspin, somewhere around 3,000 RPM in backspin. Which of those travels farther? Which one is easier to hit a home run off of? Um, and yeah, so it was pretty cool. I had a good time. Um, I mean, I also got college credit for it, and so yeah. Anyway, I probably should give you the answers. The answer is a curveball. Actually, I mean, curveball's hard to hit. That's why I always sucked at baseball when I was in high school, but I couldn't hit a curveball. But if you can hit it, if you're in the majors, uh, you have a better chance of hitting a home run off of a curveball because the backspin keeps it in the air longer. Just like if when you hit a ping pong ball, you can hit it with spin and it will actually curve. When you hit a curveball, the curve is actually aimed upward, so the ball wants to stay in the air. it's interesting. So anyway, regardless, moving on. Question number three. Using StatCrunch, find the mean, median, and mode in one output table. Okay. So let's jump back over to our data set. And remember, you want to use a uh, quantitative column, okay? When you're finding the mean, the median, and the mode, the mean is the average, right? And so you're going to add all the numbers up and divide by how many numbers there are. Now, you don't need to do that. StatCrunch will do that for you, okay? But you need to make sure that you're using a quantitative column. So this one here, inning, uh, is probably not quantitative. The inning that I hit it in, um, also, it doesn't have enough variation. There's only 1 through 9. Okay. I guess maybe there's extra innings in here as well, but uh, I need to have, according to my project, I need to have a quantitative column with a lot of numbers, a lot of different numbers, a lot of variabilities, which means the numbers have to be pretty different, and repetition, which means they actually also have to be the same. So you want some that are the same and some that are different. Okay. So I am going to use number of stadiums would have been a home run in. I'm going to use distance. Okay. How far the ball traveled. All right. So what you do is you click on stat. Okay. Summary stats, columns. Okay. So you don't have to click on them. You just hover over stat, summary stats, columns. Okay. Then you click on columns and it's going to bring this up. And so you're going to select which column. I am going to be doing distance. Okay. Now, according to the project, we want only, and this is in capital letters, only the mean, median, and the mode. Okay, so don't give me everything. Okay. Uh Later in the class we might just do everything. I don't, but and we'll just pick and choose, but I just want the mean, median, and the mode. So right here, it's selected a couple of things for me. It selected the sample size, the mean, which I do want the mean, the variance, the standard deviation, couple other things in here that I don't want. Okay. So if you click on the left in the gray box, you can select which things you want. Okay. So if I click on the mean, it's going to say, okay, you want me to calculate the mean. I could do that. Okay. If I scroll down to median and I click on that, it's going to replace it. And that's not what I want. Okay. So if you hold the shift button and click median, it'll select everything from mean down to median, and that's not what you want either. Okay. So I'm going to click on mean, and I'm going to scroll down to median, and I'm going to hold the control button on a Mac. You should use the command button. Hold the control button and click median, and now it'll select just those ones. Okay. So if you use the control button, it'll just select the ones that you are picking. So now let go of the control button. Okay. If you scroll while you're holding the control button, it'll zoom in and out. Okay. So don't do that. Okay. Uh, let go of the control button and scroll down to mode, which is at the very bottom, and then hold the control button again and left click on it. And you should have in the white box here on the right, mean, median, and mode. Okay. And we'll hit compute. Okay. So here I have my summary statistics. I have the mean, median, and the mode, just those three. Okay, for my distance column. And you can do a snag it. You can do a snippet, a screenshot of that, but you don't need to. If you just left click and drag and highlight this entire table, and then you can hit Control C to copy that over here in the project, when you hit Control V, it'll actually paste the table and it'll look nice. Okay. James, were you able to get the project saved? Were you able to do file, make a copy? Or is still not working for you? The other option is you should be able to do file, download, and then you can download that into a Word document if you have Word on your computer. I don't expect you to, purchase Word if you don't have it. So, but if you have Word on your computer, that's another option is you can do download Word. Okay, so let's go back to our answers. Okay, so using StatCrunch, find only the mean, median, mode in one output table. Okay, so later on in chapter 3, chapter 5, we'll start talking about the standard deviation and the interquartile range and the quartile one and all those different things. So when we're doing those kind of questions, you can do stat summary stats columns and click on N and scroll down to the bottom and hold shift and click mode and then just get every single number, right? So here I've got the sample size and the mean and the standard deviation and I've got all of these different things. Here's the mode. But for today, I just want those three. Okay. All right, great. So now that I have those numbers, let's look at number 4. Number 4, judging from our table here that we've calculated, what appears to be the shape of the distribution for your chosen variable? Skewed left, skewed right, or symmetric? Now, when we were doing chapter 2, the chapter 2 project and the chapter 2 review worksheet, we graphed the histogram. We did insert chart, right? And we were able to look at it and tell if it was skewed left or skewed right, right? If the tail goes off to the right, you want to ski to the right. I don't have a graph. I just have numbers. I just have the mean and the median. So how do I tell if it's skewed left or skewed right? So let's do, I don't have my visualizer open, do I? Okay. All right. So if your mean is greater than the median, then that means it is skewed right. Okay. Now, if your mean is less than the median, it's skewed left. Okay. Why is that? So if I have this graph, okay, which I don't have a graph right now, but if I have this graph here, okay, and it's got this long tail off to the right, so the mean and the median are both ways of measuring the middle of your data, okay? So the middle is like what's a normal number? So like let's say I was looking at household income, okay? Or maybe like home prices, right? Let's look at home prices. Okay. Home prices are going to look like this. Okay. You're going to have a couple of real crappy houses that are worth like, they'll sell it to you for $20,000 and it's a dump and you have to fix it up, right? And then you're going to have some 100,000. Right now, I think the median home price is somewhere around like 180,000, right? Somewhere around there. Okay. Okay. But then you're also going to have some super nice houses out here that are rare, but you're going to have, these houses that cost like $2 million. Okay. way out here. You're going to have some outliers, okay? So this is so most houses are going to fall, the highest peak of the frequency is going to be somewhere in this normal range, okay? This is going to be skewed right. Now, when we do a mean, an average, you add up the numbers and you divide by how many numbers there are. When you add this $2 million house, it's going to pull that sum way up. So mean is very affected by outliers, okay? So your mean is going to be somewhere around right here, which is like, maybe this is, 290,000, okay? That's much higher than where this bulk of the houses land, okay? So mean, average, is not a good measure for a normal home price, okay? When you talk to realtors, they don't use mean, they use median. The median home value or the median home, household income, which is what I was going to show earlier, uh, is a better measure of a normal house, okay? The median is going to be right around here, okay? Where half of your houses are below that, half of your houses are above that, okay? In other words, if I was to shade in this side and shade in this side, I use the same amount of lead on both sides. The area is the same on both sides, okay? Um, so in this case, you can see that the mean is to the right of the median. The mean is greater than the median, means it's skewed right. The mean is to the right, okay? Um, okay, so uh, let's go back to our project here. So judging from my answer above, what appears to be the shape of the distribution for your chosen variable? Skewed left, skewed right, or symmetric? So my mean, 196, is less than my median. So less than, if my mean is less, it's skewed left, right? Skewed left. Because my mean is less than my median, right?
Is that a significant difference in
Well,
baseball?
no, Lane likes to jump the gun on me. So
Oh, sorry.
no, you're
You
good. I picked
like
this
that.
one specifically because of that. So
Okay.
most of the data sets that you'll find in StatCrunch are probably going to be skewed right. And that's partly because most of them aren't going to go into the negatives. Um, but so I said a second ago, um, if your mean is greater, skewed right. If your mean is small, it's skewed left. If your mean is equal to your median, then that means you have like a normal curve, which we'll be spending a lot of time talking about the normal curve, where the mean and the median are the same spot, where 50% is on this side, 50% is on this side, but also every number that you add to the sum has a corresponding number that's going to be below the sum. So this would be symmetric. However, it doesn't have to be perfectly symmetric for me to call it symmetric. So it's not net. So is my mean equal to my median? No, it is not. Okay. But how far off is it? My distance is 396.56. So that's like, this is measured in feet, by the way. Baseball's played, we measure feet. Um, so an average home run in 2013 was 396.56 feet, which is like 7 inches, 396 feet and 7 inches. The median is 397 feet. How far off are those? Those are off by 5 inches. Those are pretty close. Okay. You have a baseball that lands here and a baseball that lands 5 inches further. They're both home runs. So um when I say equals, it probably is better if I say if they're about equal. Okay. Do a squiggle equals. So in my case, I'm going to call this symmetric because the median and mean are very close to each other. All right. Which brings up the question, well, okay, I'm using this data set. You guys are using a different data set. If I have a mean of, if I have a mean of 20 and I have a median of 22, are those close? Well, they're off by 2, okay? But in this case, 2 is, if you take that 2 and divide by the median, 2 divided by 20 is 10%. That's a pretty big difference, okay? I would say if you have more than a 5% difference, then you have skewed data, okay? Um, so on the other hand, if I have 320 and 322, those are still separated by only 2 feet or $2 or whatever it is you're measuring. But now 2 divided by 320 is going to be like 0.5%. Okay. So in that case, I would definitely call this symmetric. Those are close enough together. I would call those symmetric. Okay. So that's the long answer is, maybe if they're more than 5% apart from each other. The short answer is for question 4, take a guess and go with your gut. If you think that they're symmetric, say they're symmetric. Okay. If you think those two numbers are close enough to each other, say, yeah, I think they're symmetric because mean and median are very close to each other. Okay. Or if you're like, I don't know, well, then check which one is bigger. And if the mean is bigger, then say it's skewed right because the mean is bigger than the median. Okay. If I had put skewed left here, and turned it in, I would not have gotten marked off for that. Okay. Question 6, we're going to actually graph it and say, okay, did you get question 4 right? And if you got question 4 wrong based on your graph, that's fine. That's the whole purpose of this project, is to say, okay, there's multiple ways to measure the shape. Okay. Um, and sometimes one is better than the other. Okay. So anyway, uh, so Stella wants to know, how did I get this? So Stella, back over here in StatCrunch, if you uh, highlight your table and then hit Control C, so right click and copy, or you can just hit Control C, then you can paste that. If you want to, though, you could instead use your snipping tool, just like we did for um, the graph, right? Because we're going to need to do that for a graph in a little bit. And then you do a snip, you do a little screenshot there, and then come over here and Control V and paste that in there. So either way is fine. All right, question 5. Construct a histogram of your data with StatCrunch using markers turned on for mean and the median. Okay, so how do we do that? So let's go back over here. Now we did a histogram last time, so you should remember, right? We do graph, histogram. Okay, you're gonna select the same column that you did for your mean, median, mode. Okay, but before you hit compute, let's click on the markers here for mean and median. Okay. All right. And we'll hit compute. And there is our histogram. Okay. So we're going to use our snipping tool and grab that graph, drop it in for question number 5. Okay. Or you can do options copy and then copy the pop-up that shows up, right? Paste our graph here. There it is, okay? So the lines that it draws in here, it's supposed to be drawing a red line and a green line. The green line is the mean and the red line is the median. Now, my mean and median are so close to each other that you can't actually see them. I mean, maybe you can see a red line here. I can't. Red and green, actually, red and green is a bad choice anyway because uh, red and green are the most common, one of the most common color blindness issues. So, not that I'm colorblind, but it would have been better if I had chosen like a neon yellow here and maybe a maybe choose a light pink, maybe. Maybe that would have been better. I still can't see the pink. Hmm. Now, if you have skewed data, you'll see the red and green lines very separated from each other. Okay. Um, Also, like I said before, when you're doing a histogram, you can definitely make your bars too thin or too wide. So be careful with that. If I had done my histogram with my bars being too wide, like if I had made these like, I don't know, so like if I made these 100, oops, this is a terrible looking histogram. Okay. If I had made my bars too thin, uh, it's similarly bad. Okay. Yeah. So I can still see the shape, okay, but this is just nuts. Okay. Oh, apparently I've got one home run down here that was 198 feet. So uh that is not over the fence. So that one home run right there is an outlier that's going to, and that's probably what's dragging my mean below my median and causing me to say, oh, it's skewed left because it's below. So that would have been a inside the park home run that I should go look up the video for that one. 198 foot home run. Okay, so anyway, now that I've done that, let's take a look at question number 6. Does your graph support your answer for the shape of the distribution of your chosen variable? Explain. Okay, so looking at my graph, um, I would agree that this is symmetric. Again, it doesn't have to be perfectly symmetric. So like this bar here is a little bit taller than this bar, but I can see the overall shape. Maybe I would have, maybe if I'd done a histogram with the width at 20 might have been better. Yeah, this is probably a better looking histogram. So, yeah, this definitely looks symmetric, right? It goes up and then comes back down. Neither of the tails on the left or right is significantly bigger than the other one. So, uh, now if I hadn't changed my answer up here, if I had left this as skewed left because my mean is lower than my median, I would say down here, no, my graph does not support my answer for question 4 because this graph appears to be symmetric, even though I said it was skewed left, right? So, and if that's the case, then that's okay. Did anyone you know, have an answer for question 4? Like they said, like you said it was skewed, but it actually turned out to be symmetric, or vice versa? Or does everybody have, yes, it supports my data? What did you get?
Yeah, no, mine, let me look real quick. It says the median is greater and the mean is smaller. So I did skew left, but then my graph is skewed right.
Oh, okay. Interesting. That is interesting.
Yeah, I don't know what.
Yep. And you would just say, no, my graph actually appears to be skewed right. So cool. Yeah, so don't go back. I don't want you to go back and change your answer for number four because like I said, I want you to answer number four based on what the numbers say. So in your case, the numbers appeared to be skewed left and you have that answer correct, but then when you came down to the graph, it was different. So that's interesting to see. So that is it for the project. So in the upper right, you're going to click on share and you're going to change the general access to anyone with the link. And then you'll click on copy link and then come back over here to Canvas, chapter 3, project 1. You got to be in the student view. Scroll to the bottom where it says web URL and you can paste that URL here, okay? Now, if you downloaded it and filled out your answers, then you would do an upload, right? You would upload from wherever you saved it in your computer, okay? If you downloaded it as a Word document. Submit assignment and decorate confetti. There we go. Okay. All right, nice. All right, so oh, this is to day 4. Okay, so today we did the chapter 3 project 1. Don't forget to do the 3.3 and 3.4 lecture notes. On Tuesday, we're going to cover chapter 3 project number 3. Okay. But before we leave for the day, I want to look at the 2.3 notes Google Sheet project, which is due today. Okay. If you've already done it and turned it in, good job. If you've already done it and you're like, I'm done with it, I got it. I got it 100% right. You can sign off and, I'll see you guys next time. But if you are still working on it or you still have questions on it, stick around. So I'm going to actually stop my screen share. And I would love if there's someone who's willing to share their screen and we can go through the 2.3 notes Google Sheet project on your screen. It's coming up for us. We'll see it in
Yes.
just a second.
Give it
All
more
right, I
water.
can see
You're
it now.
just a little bit less for me.
Great. All right, so do you mind going over to Canvas and then scroll to the top?
Do my homework too. Goose. Okay, you first spell
Oh no,
goose alcohol.
go back to what you had there. Yeah. So, all right, so click on the 2.3 Google Sheet project on day 3. Keep going down. There it is. And then click Google Sheet available at this link. Yeah, let's do that. And then click on the
It's up on the table.
2.3 notes age. Yep.
Okay, why I got it black?
All right, so we have a blank one, and I know you already did it, so we're gonna make sure we don't, delete the old one. But you click on File, make a copy, okay, and just click Make a copy. You don't have to change the name of it here because if you change the name of it, then when you make a copy, it'll blow away the one that you already saved. So yep, and you can save it in My Drive. That's fine, and then click Make a copy. So, all right, great. So the first thing we need to do is the foundational midpoint, which is just the first midpoint. But you're not going to be able to do that in cell B2 because the formula for calculating a midpoint is you need the lower limit plus the next lower limit divided by 2. And that first class below 20 doesn't have a lower limit. Okay. So we're actually going to click on cell B3 and we're going to fill in the formula here. Okay. So you'll do equals and then open your parenthesis. And then the lower limit for this one is 20 plus the next lower limit. What would the next lower limit be? 30. Yep, you got it. Close your parenthesis and divide by 2. And then hit enter. Yep, 25. Good. All right. For the other ones, we're going to add the class width. So can you go down to cell B9 and show us how to calculate the class width? So it'll be equals. And it's the next lower limit, which would be 30, minus the current lower limit, which was 20. So 30 minus 20. Which we can all do that in our heads. That's 10, right? But we've seen other, class widths where, the numbers are bigger. So uh, anyway, so the class width is 10. So let's go back up to cell B4. And you're going to do equals, and we're going to add that class width. So you do equals, and then you click on the 25 above it, the previous class width. Yep. And then plus 10. Nice. And hit enter. And that one's 35. Yep. Good. So now that you got that, we can get the rest of the class widths. So we can copy that formula. So for that one, for cell B2, you're right that it's 15. How did you get that? You did equals 25 minus 10, right? Yeah. And that's what we have to do when the first class doesn't have a lower limit. Okay. Okay, so go back and click on cell B4. We want to copy the cell value. We want to copy the formula, not the value. Copy the formula there for the rest of the blank cells there. Yeah, just like that. Nice. All right. Next, can you show us how to get the total? Oh, so you got to put parentheses between the M and the C. So double click on that. Oh no, you don't have to delete it. We can just fix it. Yeah, you want some parentheses C2 through C6. Yep. All right, good. So how many users do we have? We have 1,622 users. That sounds good. All right. So now that you have that, that will allow us to calculate the relative frequency, because the relative frequency is the frequency divided by the total. Mhm. So you got to click on the D at the top, or you can just highlight them. Yep, that's fine. Good. Now, if you're going to use Google's suggestion, we don't want the 1 at the bottom. That 1 is dividing 1,622. It's dividing 1622 by itself. And that's always going to be 1, and that doesn't really tell you anything. So, all right. All right, next, let's get the cumulative frequency. So the first one matches the first frequency. Okay. And we don't want that last one. Yep, correct. Um, so can you do me a favor? So go up to the first cumulative frequency and change it from 403, change it to equals C2. Okay. So it's still 403. Why does that matter? Why did I make you do that? So for cumulative relative frequency, I said that there were two ways to do cumulative relative frequency. And I showed you one last time, which was you take your relative frequency and you divide by the total. Okay. And we could do that here, but I'm going to show you a second way, which is a bit faster. So if you take, can you highlight from cell E2 down to E6? Highlight all of the cumulative frequencies. Highlight all the cumulative frequencies. Yeah, there we go. If you highlight all of those are all formulas. Those formulas are taking your frequencies and adding them up over class by class by class until the very last one, which is always going to be matching the total. Okay. Those formulas can actually be used exactly as they are for the cumulative relative frequency. So can you copy those over to the next column? And there it is. And so if you, as long as the, oh, wow. So as long as cell E2 is a formula, when you copy it, click on cell F2. You'll notice that if you click on cell F2, click on the one above it, when you'll notice that it didn't copy it as equals C2. Google Sheets was smart enough to know, oh, we shifted over a column, so you don't want C2 anymore. You want to shift over a column and grab cell D2, which in this case is the first relative frequency, and that's exactly what you want to do. Okay. So either way is fine. You'll notice that I know that these numbers are right because the first relative frequency matches the first cumulative relative frequency, and the last one is 1.0. Okay. So if none of that made sense to you, that's okay. You can just do it the way we showed you last time. I said there's two ways to do it, and that's usually the case in math. There's lots of ways to do things. So yeah, so now that you have this, the last thing is we would graph, we would highlight our frequencies and then do an insert chart. And this one, I think this one is still skewed right because you can have a tail off to the right, but it's a little closer to symmetric than some of the other skewed rights that we've seen. So, okay, and then you would share this with me and submit it. Now, Montez, I know you've already submitted yours, so you don't necessarily need to uh, submit it again. But yeah, thanks for sharing your screen with us. So. All right, that's it for today. If anyone has questions, please stick around. Otherwise, I hope you have a good weekend. Elaine will see you on Monday, and I will see you on Tuesday.
Have a good weekend. Let's just survive it.